everyone. Any questions? Questions? I have no idea where you go for tutoring. It's supposed to be posted at the department office.
Duncan Hall, it's either the second or fourth floor, and there's tutoring like 4 or 5 days a week. It's like
Yeah.
for Java, it's great.
Yeah. Okay, so there's two different resources for tutoring. So the Duncan Hall, I believe, is the College of Science. Is that correct? Okay, and we have one person who says it's awesome. So that's great. And there is another set of tutoring that's done by the computer science department, and I have no idea where it is. It usually is at or near the computer science club, which, by the way, you should all join. It's a great resource. And so ask in the department office, McQuarrie Hall, second floor. And yeah, some of you try out both and give recommendation of which service is more awesome. By all means, bring your Ailing homeworks there and let them help you out. This, as you notice, it's getting harder pretty quickly, and by all means, take advantage of it. One thing I wanted to point out is someone asked a couple of days ago in Piazza, when are the exams? And then I hastily put in the wrong dates, so I fixed that. So these are the correct exam dates. So if any of you have already put the old dates in your calendar, just update those. All right, so you find those on this page. Other questions? Yes?
Is that saying that exam 2 is on November 14th or on the 19th?
On the 14th.
Okay, that's...
The 12th is no class, right? It's Veterans Day.
yeah, okay.
And it's on the 14th. But that's a good question, and if you put that question on Piazza, I will make it so that the 14 also shows up in bold. Or I put in like a little arrow to the left or something. Yes, absolutely.
Great, thank you.
Yeah, that would be no fun if someone showed up 5 days later.
I was talking about the
McQuarrie Hall. All right.
they'll sit down, there's usually a couple people in there.
Yes. Yes. So those people I know to be good, usually, and the one I just don't know the ones in Duncan Hall. They're the ones who showed up last time with that flyer. So try them both. Other questions? There can't be no questions.
Piazza's just working too good.
What's that?
Piazza is just working too well.
Yeah, that must be it, yeah. But I know from personal experience that people come to me and say, what's Piazza 4 weeks into the course? I'll give you another chance a little later if we have some extra time. So generally what happens is that after the draft, people have all sorts of questions about the homework. And it's not happening. No one has a question about the homework? Come on, someone must have a question about the homework. Otherwise, I'll make it harder. Yes?
So I completed and submitted the draft.
Yeah?
When I ran it through the final version, this is the plus 2.
Yeah?
It's not incrementing. I guess I don't understand what exactly is going on there.
All right, let's have a look. This is, okay, homework 3, right? So, and it's part B?
C, I believe.
Part C, okay.
Yes.
All right, let's see what the draft was asking for. Bug lives in a two-dimensional grid.
I think we came to the conclusion that the draft was like the other one where all the return operators just return 0.
Yes, yes. So the draft just returns 0 and everything, right? So let's make it really quick. If we haven't already done it. Here it is. So yes, so this all returns 0. Let's see how NetBrat goes with it. So this code here, which does absolutely nothing, right? It doesn't implement move, it doesn't implement turn, it just returns zeros out of the getters. It'll pass the draft tester because that's all that you were expected to do in the draft. And so this was all supposed to like seed your brain with some degree of nervousness that now at some point you actually have to implement all of these methods so that you start asking questions. And how am I supposed to do that for the final, right? If you paste this course, this code here into the final, it has no chance of coming anywhere close, right? So here we have a big fat tester, and that tester is going to have to fail just about every single test because we're not yet doing anything at all, right? I mean, how could it work, right? It just returns 0 all the time, and this bug actually is crawling around. Let's see what this bug is doing. It starts out at position 0, 0. So let's just sketch this up here really quick. So it starts out at 0, 0. Then it goes, then it moves. And so that means it goes here. Come on. Right here. Then it moves over here. Then it turns. So now it faces, no, it moves one more time, right? We move, then we turn, and then we move again. So we move one more time, so now we're moving here. Then we're turning, so we face downward, and then we move, so we go here. So that's the trip of the bug. And when you look at the expected positions, they're exactly what you see here from the picture. But of course, so far, our bug has no chance of passing these tests since it does exactly nothing. Right? This is exactly as if you were to come to the final of this class, prepared exactly nothing, answered 0 to every question, you wouldn't pass the final exam either. So that's the analog. So what do we have to do? We have to now start working really quite hard to go from here to there. And so we have to figure out, what does the bug need to remember? It needs to know where it is, right? Its position. So that's an instance variable. And then there was some hints in the way the question was worded to get you to that it should know the direction. And the direction, because it can go left, right, up, or down, there's various ways one could represent the direction. And that's totally our choice as designers of this class. You could say the direction is represented as a string, like east, west, south, and north. But that makes it hard to implement the move. So it's actually easier to implement the direction by saying, how much should we change the x value and how much should we change the y value? So when you look at the little picture here, when the bug is facing east and it moves, well, moving east means that you move in this direction, and that means that the y value doesn't get changed. That's why there's a 0 here. And the x value gets 1 bigger. That's what this 1 means. Moving south means that the x direction doesn't change. That's why we have a 0 here. And that the y value gets 1 smaller. That's why there's a -1 here. Yes?
So it's actually, when the y value is going down, that means it's moving when it's turning, right?
It means it's moving. Because when it's turning, it turns in place.
Yeah.
Right? When you turn, you don't change where you are.
But why is the y-axis, that's where I can figure out why is it going -1 if you're not actually moving two different ways, if you're moving along the y-axis.
The dx dy values say if one actually does move, how does the move work? So the meaning is, how do x and y change when you do the moving?
Oh, okay, so it's just setting it up.
It's just setting it up so that in the future you move along those directions. So when you turn, you prepare those values for a future move so that the future moves work the right way. So we need to put those in here. So that the bug remembers its direction. And so we're just going to be using this encoding for the direction here. So then you need to implement the move method. And that actually, okay, how do you move? So you could program it like this. Or you could simply say, and I'll do it the easier way for the y, you could simply say y equals y plus dy. So in the first example, I just, for greater clarity, I moved the new value into a separate variable, and then I set it so that you can see it in 2 steps. Here I've combined the 2 steps. So you can implement the move like that, and that's actually not bad. Let me copy the tester over here. So it's nicer to have the tester local, so you don't have to always go back to NetBRAD. So I'm just going to copy it out. And now I can run it, and that doesn't look so good. It still returns 0 all the time. That's not fair. I've done all this work. I've put in instance variables. I've implemented the move method. Why does it still return 0? Yeah, because I never got around to fixing the getX, getY. So let me actually return x and y. Okay, 0, 0, 0, 0. Okay, so this one's better. This one is not yet good. Let's have a look. I have no idea. But I haven't called churn yet, so it should be okay. Right? Does the tester, it calls move.
But your variables don't have any values. The dx and dy don't have any values to add or subtract.
Ah, very good. So let's play through what move does right now. So the way to do this is you make yourself a little table that shows what the variables currently are, x, y, dx, and dy. So I've constructed the bug, and now what's x? 0. Everything that you have not initialized is 0. So these are all 0. And now when we do this computation that you find here, then you notice it computes 0 plus 0 and sticks that back into x. So that's no good. So my mistake was that I didn't set up dx. I want it to be 1. Where do I initialize it? In the constructor. It's the job of the constructor to initialize the instance variables, and it's actually a good idea to explicitly initialize them all. That way you won't forget. Okay, we're initializing it like that because the bug starts its life, like all bugs do, facing east. And now when we run it, oh, now it's getting better. Right? And so now we have matches here, 2 expected 2, 0 expected 0, 2 expected 2. So down here, it's not yet working because of the turn thing, but you have a few days to figure that one out. So that's how it goes. Any questions about this? Yes. There was a question there. Yes, no? Okay, hang on. You mean how did I find this out? If we look back at the homework assignment, so it gave this tantalizing hints that these dx, dy are the changes in x and y as the bug moves along. So let's look at a particular scenario. Let's say the bug is currently at, let's say this is x equals 1 and y equals 2, okay? And now the bug still is facing east. It hasn't turned yet. And now it moves. Well, when it moves by one position into its current direction. So it moves over here. So over here the position was x equals 1, y equals 2. And here it's x equals 2, y equals 2. So when you move east, then you add 1 to the x position, the y position is left alone. That's what these two numbers here mean. So in general, that's how the move works, that you always modify the x by the dx value, you modify the y by the dy value, and by cleverly setting them in one of these four ways, you get the four compass directions. So if you want to try out another one, let's try moving down. In that case, we would add 0 to x, minus 1 to y, then that would get us down here, and that is in fact the downward motion from where we were before. So make the sketch on a piece of paper and make a couple of calculations like that to convince yourself that adding those values makes the bug move. Other questions?
What if we use a different way of calculating it?
If you used a different way of calculating it, that's fine. The grader would look at it and say, that's odd. There's nothing in the rubric that says you have to do it in a particular way. So if you have found out how to make a network connection to Siri and ask her what the next position should be, that's fine. Yes, questions? I'm sorry? Why did I put return? You mean here? The job of the getter is to return the current x value. So any getter will return some value, and as we'll see in today's lecture, I believe, the return statement does just that. It returns a value out for an accessor. Notice that all of those getters look pretty trivial. And we'll see, I believe today, exactly why we have to have the getters in the first place. So a getter would usually just get some value that's either an instance field or that's simply computed from the instance fields. Yeah?
Regarding the statement of the static void main,
Yes?
how come when we're starting to use testers, we don't even have the other one? Maybe use that on the first class?
Oh, the bug class?
Yeah.
Okay, that's a very good question. So his question is, why does the bug class not have a public static void main? And the answer is the bug class is not a program. The bug class is something, it's like the string class or like the bank account. It models something in the real world, but it's not an executable program. So I couldn't run bug by itself. In order to run bug, I need a second class that constructs bugs and does something with them. And so that would be the tester or a bug demo or some such thing. So from now on, where we're going to be working on our own classes, typically our projects have more than one class. The class that we're actually interested in, the bug or the bank account or the love letter or whatever it is that we want to implement, and then a second class that executes our class in some way. The bug tester, the love letter demo, that kind of thing. And so that's also one reason why I said it's a good habit to make a separate project for every single assignment, because now as they get more complicated, it's nice to have the classes that belong to a particular assignment together in that project and not any of the others. Like, for example, in homework 3B, You also have a bug tester, I believe. Do we have a bug tester in 3B? And see, now you have a bug tester in 3B and a bug tester in 3C, but they're different bug testers, so you want to have them separated in different projects. Yeah, you can do that, but the danger with that is, in homework 4, you're going to have to turn in those testers, and then you have to remember to unrename them, because otherwise NetBrat will complain. So you really are better off having a separate project. And so what? I mean, there's going to be, what, 15 homeworks maximum? Say 13 times 3, that's 39 directories. That's nothing in the grand scheme of things. So just make a separate project for everything. The other thing is when you do it like that, and after a couple of times doing it, it becomes second nature. You just make a new project, and your fingers know how to do it. And then when the exam time comes where you have to do this, you just blam, 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 make it. You don't think about it. And then if in the exam there was something with conflicts between the two, it wouldn't trip you up. So just go with the flow and make a separate project for everything.
For homework 3.8, there's a bonus question where you include the Gregorian calendar.
Yes, but don't turn that in, right? So if you want to work it on your own and figure out how to make a voting machine that rigs the election, then, by all means, go it and try to figure it out. You can post questions on Piazza and I'll be glad to answer them, but don't turn it in, okay? Because for all you know, by sheer accident, the grader might be running that thing on election day, and well, presumably it won't, but still, don't turn it in. So what was it?
But in order, because the way it works is that we have to somehow, I guess, nod the party that wins. But aren't we using the tester to call a method through the class first? So we have to also.
You have to set your computer's clock to election day if you wanted to test it. Yeah, that one would be difficult to test.
Yeah. We have to call that method in the tester, right? Or you have to add that.
Not in the tester. The tester treats the voting machine as a black box.
Okay.
So inside your black box, you would probably rig the method that says get Democrat votes and get Republican votes. You would rig it so that it would give the wrong answer on election day. I put that in the book only so that you could think about what actually does go on in these electronic voting machines. Right? You can go nowadays. Most voting is done with these machines, and it actually is something where computer scientists are very unhappy about it because no one really knows what goes on in those machines, and it is quite easy, surprisingly easy, to manipulate them. So it's entirely possible that someone could pull off a widespread fraud with one of those machines, and it's probably not a good idea. Yeah?
So when you were showing us sort of example code for moving the bug in the move method,
Yes?
you had integer UX, like you made a new variable UX.
Yes?
Is that actually necessary?
No, it is not necessary. I just did it because I thought it might help some people break it down into 2 steps.
Oh, yeah. I was just checking because I
No,
noticed.
it is totally not necessary. And even in the book there, it's done with a bank account. It's done in 2 ways. You will sometimes see code where it says balance equals balance plus, and sometimes you'll see new balance, and then it sticks that back into balance in a separate step. So you should be able to read both ways, but when you write it, pick whichever one you find simpler. All right, let's move on to the lecture. All right, a couple of reminders. There's still a bit of confusion about Canvas. It is possible to send a message in Canvas or to put like a comment into the Dropbox. And whatever you do, don't do it because those things go nowhere. So any kind of message, I fished out a few of them where someone says, why did I only get 13 out of 14? And no one is going to read it or answer it. If you want to get a question to me, you can ask the question on Piazza if it is of general interest, and I assure you this particular question is not, or you can send an email and I will look into it. Just a regular old-fashioned email. If there's something that deals with your lab assistant, like this one said, oh, I had no lab partner, you need to contact your lab assistant. You should have some way of contacting your lab assistant. He or she should have given you a favorite way that they wish to be contacted, probably by some kind of an email. And as an aside, it can't ever happen that you have no lab partner. There never is a situation in the lab where there's only one person working on something. It's either 2 or 3. There's always a bunch of 2s and just one with 3. You will not get a point if you don't work with someone else. So this poor person, unfortunately, is not going to get a point for this particular lab. Next, Canvas has this irritating habit where it asks you to give 3 different versions of your name. First name, last name, another one, first name, and then the last name, comma, first name. These 20 people have not done that. If you find your email address here, unless you have actually changed your legal name to admin@scos.net or whatever, please go in there and change it. I cannot otherwise give you a grade later. I'm not going to play detective and figure out who this is. I've sent you a bunch of emails already that those 20 people have either ignored or they ended up in the junk mail, who knows. So fix those. Thank you. Moving on. So our first example of an actual class to show how one does this coding, which I realize you're busily doing in the homework already, is this little tally counter. It was the simplest example of something that does something that I could think of. So you've seen these tally counters. Sometimes you see them when someone does measures how many people enter the train or a bus or something, or you see it at a theater venue. Every time someone passes, the operator clicks this button, and that number increments. So now we want to model that in Java code, for no particularly good reason, except to have a very simple example of modeling some real thing in Java. So this is a simulator of this counter. So here's some sample code. So we're making a new counter object that returns a blob whose internals we don't really know, of class counter. What's inside? Something. It can execute a bunch of methods, and so we're going to call the count method. We're going to call the count method again, and then we're going to call the get value method. That's an accessor that tells us what the current value is, and in this case it returns 2, and so the variable result here is set to 2. So that means each of these counters, and notice I could have more than one, right? You could have one for the front door and one for the rear door of the theater. Each counter has a separate instance variable that remembers how often it was clicked. So, do we have it? Here we have it. So the syntax goes like this. You have the name of the class, and inside here you put private. Instance variables are always private. You put the type, which is, in this case, int, because a count is an integer, and you can give it any name you want. So in this case here, value sounds like a pretty good name for it. It's the current value of the counter. You could displayed number, whatever you want. So this picture just wants to show that if you have 2 different counters, each of them has its own instance variable. So each instance of counter has its own local memory, and the settings of them might be different. This counter here might say 37, and this one might say 122. Yeah? Can we do that later? This I'll just tell you what it is. But in a method, which we haven't even covered yet, in a method, this is a reference to the current object. So inside a method, this would be a variable that points, say, to this one, if that's the one that we actually call the method on. But hold that thought. Yes?
I don't know if it's values or not, because these values are extras, right? That means that they're stored in the variable.
Yes? That's true, but it doesn't really matter. All right. Now when we implement a method, then we can access the instance variables. So here's the count method. It takes the existing value, adds 1 to it, and sticks it back into the value variable. The get value method takes the current value and just returns it to its caller. Now, it sounds like a lot of hassle to have both the instance variable, value, and this method, get value, but there is a good reason for why we want this. And that is, as a general rule, you want to leave the instance variables of a class private so that you can change them later if the need arises or if it just turns out to be convenient. So we will always leave the instance variables private. And there are many situations where there's more than one way of representing the state. For example, with the bug 2, we've had this complicated scheme with the dx and the dy, which actually is kind of convenient. But another way that I said before that one might have implemented is to use a string, south, east, west, north, which might have other advantages or disadvantages. And it's very common as one implements a class that one goes back and forth between these, and that's fine as long as the users of the class don't have to worry about it. And so the users of the class should only worry about what are the methods, what can the public do with it, and what goes on inside should always be private. And all of the classes that you've used so far, like rectangle or string, work in that way. You don't really know what goes on inside a rectangle or a string, and you don't really want to know, so those things should always stay private. That whole process is called encapsulation. Encapsulation means you hide what goes on inside, and you make only public what a user should know. And it's something that you find all the time. And for example, if you think about your car, that you know what happens when you push on the gas pedal, the car goes faster. But how that works, do you actually have a clue? I mean, something must happen, right? More gas gets squirted into some I have no idea. And in fact, when the implementation of the car changes, as sometimes happens now when the cars have electric or hybrid motors, I would imagine with an electric motor, there's no gas squirting anywhere, right? There's some voltage. I have no idea. I'm a software person, not a hardware person. And the user interface hasn't changed. I can drive an electric car. Its internals have been completely changed just as much as another. So it's encapsulation at work. I know the user interface, and I don't have to worry about the implementation. And so the same boundary happens when we implement our own classes. All right. So let's, never mind that typo there. Let's look at this hypothetical situation, a little bit contrived. Look at the counter class, lovingly implemented by coder Carla, and she refines it over time to add other wrinkles to the counter. I don't know what they might be. And programmer Paul uses that class, and now something odd happens. So he has some counter, he calls the value, and it prints a negative number. And so the question now is, who is to blame? Option 1 is that programmer Paul was delusional. This can't ever happen. Option 2, something with integer overflow. Option 3, it's Carla's fault. And option 4, Paul messed up. So let's get this to Piazza real quick. Oh, I think I have Piazza running. Yeah, it's already there, but it's not active in some way. They have a new feature that I'm going to try out right now, where I can hide and show these clicker questions or deactivate and activate them. Okay, it says I can make it. Hey, no fair. I know it's now closed. How do I open it again? Okay, obviously messed this one up. I'll just redo it. Is it? Oh, it's a note. It's not a poem. Okay, here we go. Well, it's the same thing. I thought I hid them or something.
Oh, maybe that's refresh.
I'm about to delete them. Come on, Piazza.
The one is the correct one.
Yes, let's do one. I don't think you can do the others. So much for this new feature.
Is there a way to such that become active at a certain time?
Well, that's the thing. Now, when I click on edit, it doesn't let me edit it right. I'll have to ask the guys what they were thinking. They were so proud of it, too. All right. 54 so far. Get this number up a bit. All right, there's over 120 people in the room, so
He's telling me please look for someone.
all right, let's see. So 25 people, or 22%, said this can never happen. And that seems like a reasonable thing, except sadly, it's not true. So it turns out that if you click on that thing a bit over 2 million times, then it exceeds the largest possible integer value. And unless your code catches that situation, then it would actually go and turn negative. That's just the way that integers work. But of course, it is a bug, right? It means that what Carla should have done is that she should have said, if this is the largest possible integer value, and then one tries to click again, then something should happen. Either it should stay at the largest possible value, or the keyboard should melt into a puddle of plastic, or something. And so Carla really should have dealt with that situation. And if she didn't, it kind of is her fault, because when she sells this class to someone and says, you guys can use it, it works great, then it also needs to work in this particular situation. Now, of course, if Carla is in week 3 of 46A, she doesn't yet have the tools to deal with this thing, but you guys will in a few weeks. So it really is a problem in Carla's code. So when you use someone else's class, then you can rely that that thing works correctly, and if it doesn't, there is a bug. This actually happened to me this very morning. there is a wrinkle in NetBrad where the grader can submit all of your a zip with all of your answers, and Java has a class that can unzip the zip file, and that crashed because one of you has a name with an accent, and whoever implemented that particular thing at years ago, probably at Sun Microsystems, didn't handle this particular situation with decoding that character, and it just blew up. Those people are at fault. It's not me. I used the class. I have every right to assume that it works correctly, and those people messed up. So what the encapsulation gives you is a way of apportioning responsibilities. It's the responsibility of the implementer of the class to make the methods work correctly. So of course the implementer of the user of the class to get the rest of the code worked correctly. So Paul is blame-free, even though sadly 20 people were going to shift the blame to him. That's the way it goes in life. And Paul did nothing wrong. So Paul, in fact, can't do anything wrong because Paul has no way of reaching inside that object and changing its internal state in an illegal way. Paul has no way of accessing the instance variables because they're private. So when you use a class, you can never access what goes on inside. And conversely, when you implement the class, you can be sure that no one else is going to modify those, only you. All right, so that was encapsulation. Back to public interface. When you design a class, and that's actually not something that you're going to be doing for a few more weeks. With all of the classes right now, I will design them for you. I will give you the design. I will tell you what methods that class should have. But let's go through the entire story of how a class springs into life. Someone out there says, oh, we need a class to fulfill a particular purpose in our bigger program. So like this might be a program, a banking application. So someone says, we need to model a bank account. And then you brainstorm and say, what should a bank account be able to do? Well, what does one do with a bank account? You put in money. You take out money, and you want to know how much money is in there. Those are kind of the most basic operations for a bank account. And let's say we want to stop there and just model these three. Then you ask yourself, okay, how should they look like in Java? And one way that I like to do that is I just like to imagine, how would I use this class? How would I use an object of this class? What would the method calls look like? Because you've already used a few classes. You've called methods on them, so you have a feeling for what a method call should look like. And so here's how one might use a bank account. So here's my bank account object. I want to deposit, so I call the deposit method. Seems like a good name for it. And I have to say how much money should I deposit? Because that parameter is important. I can't just call Harry's checking deposit. How would it know how much? So you have to tell it how much. Same thing with withdraw. You withdraw, and you have to say it how much. And then finally, you want to know how much is in there, so you would call get balance. And that's just an accessor, doesn't need any parameters. You just ask it, and what's your balance now? So that's how you would like to use it. And once you have that worked out in your mind, now you're ready to write up the method declarations. And you've already know this from the stubs that you've been doing. A method declaration has this format, name of the method, preceded by the word public and the return type. The return type is void for a mutator, and it is whatever it is that you want to have returned for an accessor, such as int or double or string. And then you list any parameters, any inputs that the method needs. To deposit, you need to know how much. So a parameter has two pieces. It has the name of the parameter, and you can name it anything you want. You could name all your parameters Fred. It would just make your program harder to read. The type, of course, has to be exactly the type that you want. And here for money, we use doubles so that you can represent both dollars and cents. Now inside here, it says the implementation fill in later. And you see, that's what we did for these drafts. We just leave it blank for right now. And later, in the final version, when we know what we're doing, we actually fill it in. So you make these method headers here. And here you see the method headers for the three methods that we've dreamt up for the bank account. Now you do the same thing with the constructor. Remember that a constructor is used whenever you want to make a new object. And they look a little bit different. You have the keyword public again, because all methods for right now are public. There are private methods, but they're not common in a beginning course. You then have the name of the constructor, and it is the rule in Java that the name of the constructor is the same thing as the name of the class. Notice there's no return type. And that's actually a nasty pitfall if you accidentally put the word void in here, for example, or int or double. Then what you get is a method and not a constructor. And you get bizarre error messages later. So that's a nasty pitfall in Java. It's too bad that that's legal. So make sure not to put in the keyword void here. Someone will do this, and we'll see it on Piazza. So what do you put inside the constructor? Well, we'll see that later. But what you do is you initialize the instance variables. You can have more than one constructor. Later, the bank account will have a couple. Yeah, here we see that. It has one that makes a bank that starts out with a balance of 0, and here's one that has like an initial deposit, which is typically what actually happens in real life when you open a bank account. So notice again, all of these methods here are method bodies are blank. When we do this with the testers, you would fill in down here, you would put in a return 0 so that it compiles. All right, we don't need any of this. All right. Now, let's see that you can use this bank account from the public interface. So have a look at this code, and I'm asking you, what does it print? Down, so. Four. All right, so let's see. So we have a bank account. We started out happily with an initial balance of $10,000. Now, in the next statement here, we're withdrawing something. How much are we withdrawing? Well, the get balance returns 10,000, so we are withdrawing $10,000. Now we're depositing something. How much are we depositing? What's the balance? 0, and then we print. So it should print 0. Let's see whether everyone got that. And interestingly, I'm not able to make the point that I wanted to make. The point that I wanted to make at this point is, oh, see, it's so easy. You can use this class, and you know exactly what you're doing, even though you have no idea what goes on inside it. And it's not actually true, because 34% got the wrong answer. But if you guys would just think harder, you could use it the way that it is intended, and you don't have to know what goes on inside. So I guess where people tripped up, okay, I have no idea. Wait.
They thought that you were getting the original balance.
Aha. See, withdraw is a mutator. It changes the balance. So after the withdrawal, the balance is 0. Right? And over here, we're calling get balance again, which now returns the updated balance 0. And now we're depositing that. Try this out sometime. Go to your bank. Say, give me all my money. And then ask, how much do I have now? And then say, that's what I want to deposit. Right? And see what happens. Yeah, and then you're going to have to say, and now how much do I have? Right? Because that's exactly what goes on. Yeah. Harry goes to the teller. How much money do I have? Give it to me. How much money do I have now? Oh, that's what I'm going to deposit. And now how much money do I have? So those are the questions that you answer. Yes. All right, now here's a more interesting question. So let's say I want to make my bank account more powerful. I want to store the account number in addition to the balance. And so now we have to start implementing that. And so that might be a change in the public interface, because somehow one needs to be able to get at that account number or set it or whatever. So ponder these 3 choices. Should you add a get account number method? Is that a good idea? Should you add an account number parameter to the constructor? Should you add an account number parameter to the get balance method? And then which of these 3 should you do? And there's a bunch of combinations listed here. So let me set that up. Right now we're kind of silent on that, but yeah, it could be a string. Yeah, I didn't ask that question, but that would have been a good question to ask. What was the right data type for it? I'm simply asking if you added in some data type. All right, so let me visualize my bank account object here. So I have some blob. All objects are shaped like blobs. There's some money in here. And now it also has an account number. Sounds like a good suggestion that a string would be okay. But it's somewhere inside there, so I can't really see it. I'm just visualizing it. Now I have this thing, and later someone maybe gives me a different one, and I guess I kind of want to know what is the account number of that particular object. And so it would seem eminently sensible that I would want to have a method that tells me. So I would think you really do want to have that method. In general, when an object contains some amount of information, you need to have a way of getting at it. So a bank account has a balance. You have get balance to get at the balance. And if it also has this other feature, you kind of want to have a way of getting at it in some way. Now, when you construct a bank account, you also have to be able to say, I'm constructing a bank account with $10,000 and with this particular account number. So this would be a good option. There would be another alternative. You might have a separate method to set the account number, but that wasn't one of the choices. So what about the get balance method? Does it need the account number as a parameter? So now I have this particular bank account, the one that you see here, and I'm going to ask it, how much have you got? Should that method call have a parameter? No, because to ask it how much has it got, we already have the specific bank account in front of us, so we don't have to again ask to tell it anything about the account number. A different method would benefit from a parameter that says account number. Namely, in the entire bank, there should be a method to find a particular bank account. So if we had a bank class with a find method, the find method would benefit from that parameter, but the get balance would not. So let's see where we are. And I kind of expected that quite a few people would be somewhat confused about that. So it's important to realize that for get balance, you already have a specific bank account in front of you. And that one has a balance all by itself, and there's no point of saying, hey, bank account 8859-1, what is your balance? Because that's the only bank account that you're currently working with. There's no other bank account around. And so there's no need to reference that again. Maybe it's different than with people. You know, you walk up to someone and say, hey, Joe, how do you feel today? Even though it's completely pointless to say, hey, Joe, because you and I know it's Joe, right? But that's the way it is. All right. Last thing, commenting the public interface. So that's something that we haven't done yet in the homework, but it'll soon come. When you write a method, you always want to comment it using this very particular style of comments. So here we see the withdraw method. We still don't have an implementation, but we already know enough about it to write the comment, because the comment is for users, not for implementers. So here you see the purpose. The purpose of this particular method is to withdraw money from the bank account. And there's a documentation of this parameter, the one that you see here. And the way that works is you say @param, followed by the name of the parameter. You must mention the name because many methods have more than one parameter. And you need to say which one it actually is. And then you give the explanation of this parameter, the amount to withdraw. And the same thing here for get balance. Gets the current balance of the bank account. And then this one doesn't have parameters, so there's no @param, but it returns a value, so there's an @return, and then there's an exclamation, what it returns. So notice that there's a lot of stuff in here. What happens with that stuff? It shows up in these Java doc things, so you can run a tool that generates those comments, and then when you give your class to someone else in a bigger project, they would just read through the Java docs in exactly the same way that you've been reading them. You know, when we've looked at Rectangle, for example, Here's the rectangle class. And you've looked at this documentation. And so you've looked at, for example, at grow. Let's look at grow here. Now, you've seen this. And let me show you where that comes from. When we look at the source code of the rectangle class, here it is. Here's the implementation of grow. And there's some code in here. We don't really care what the implementation is. What I care about is this comment here. Notice this comment. So it has these characteristic slash star star markers. It then has a bunch of explanation, nicely formatted in HTML. You don't have to do that. And then over here you have at param, the horizontal expansion, the vertical expansion. And look here, this is what generates this. So the tool takes the source code and automatically generates the set of linked HTML files. That tool is called JavaDoc. And when it first came up, like almost 20 years ago, it was really a very, very nice change from how things used to be done. It used to be done in the bad old days that you would hire a tech writer to write the documentation in a Word file. And so they would write all of this stuff. Kind of like what you see here, except it was written in a separate document. And then what happened over time is that the implementer, let's see who the implementer was. You can actually see that in here. Sometimes it has a name. Let's see if we find a name in here. No, these guys were anonymous. But in some classes, you actually find the name of the person who did it. Let's say Joe Smith wrote this class. And then Joe Smith made a change, a significant change to rectangle, maybe added a new method. The tech writer had long been laid off, and the Word document was out of sync with what was actually happening. This always happened. In every single project that anyone had ever been, the documentation drifted away from the actual code. And so then the people who invented Java had the bright idea to say, let's do away with the tech writer. He never knew what he was doing anyway. Let the programmer write the documentation, and that way when the programmer makes a change, it's an easy matter for the programmer to change a few words in the documentation, and that way they're always in sync. So nowadays the idea is that a programmer is a human being who can write documentation, and that's what should happen. Now notice that this particular programmer wrote a lot of documentation, right? I mean, there's every single method here is documented. There's not a method in this file here that's not documented. Here, get width. Look at how long the get width method is. Look at how long the comment for the get width method is. It's a lot longer. You don't have to do HTML, but all he does in HTML is he writes code around these things. Let's see why. The only reason is that so that inside, here, where it says the bounding rectangle, notice that the word rectangle is in monospace. And so he felt strongly, or she felt strongly enough about that they wanted to actually make the formatting. That's not something that's all that common. So I rarely put actual HTML in there, only if there's something where the HTML is really, really helpful. So you don't generally need to do that. This person, I think, was kind of overdoing a double precision. Whatever. You can, but you don't have to. The point, though, is that every single method that you write should have a comment. It should look naked to you if it doesn't have that kind of a comment. So I will, at some point, crank that up, starting from the next homework, that the rubric will say, does every method have a JavaDoc comment? 2 points, or some such thing. And you will lose those points if you don't put them in. Now, it is no secret that every programmer does find this part of the job intensely boring, particularly with a trivial method like get width. Well, yeah, it returns the width. And that's just life. And notice you have to say it twice. Returns the width of the bounding rectangle in double precision. At return, the width of the bounding rectangle. He wrote it twice. Twice he wrote it. And it was boring. Boring it was. So it's just the way it is. And there's no tool that can replace the human intellect here. Some of these methods are pretty boring to document. Some of them are more interesting to document. But as a professional, one does the boring with the interesting. And these guys did it. You know, these guys were highly paid software engineers working for a big corporation, and they would write returns the width of the rectangle. And so in our lecture here, no, in our book here, it says withdraws money from the bank account. You know, duh, it's called withdraw. What else is it going to do? But we write it anyway. And what is amount? The amount to withdraw. What else is it going to be? But you write it, and you're rewarded later when you extract the HTML, which you will do in a lab, with nice-looking HTML that looks exactly like the HTML from the pros. All right. So let's do this with the... My self-check didn't materialize. Well, that's mean. I had a beautiful self-check, not a clicker question here, but here it is. Okay, never mind this self-check. Here's the clicker question. Okay, and it is a beauty. All right, so what's wrong with this documentation comment? Because it takes practice to do these well, so I'll give you a bad one so you can... critique it. Show names to everyone. Oh, yeah. You guys can browse the slides. They're right online. All right, come on, guys. All right, so in the interest of getting us out of here, let's go from the end. The return statement does not end in a period. I'm not going to belabor the periods. Actually, the style guide says that the description should end in a period, but you won't get any error message if it doesn't, so it's a minor point. So those periods are optional. The return statement does not include the name of the parameter. Huh? There isn't even a parameter, and what does return have to do with the name of the parameter? But as I anticipated, there is a number of people who had that answer. So those of you who have that answer, make sure that you understand the difference between a parameter and a return value. They're important concepts. And if you don't, ask questions about it. Here's the other one. There is no param statement. You can omit, well, there's no parameter, so you have no param statement. And finally, the description does not specify the purpose. And it doesn't, right? Each account has an account number. It doesn't say what this method does. Now I've put that thing here because I see that so often with students' attempts at doing JavaDoc, that they'll write any old random stuff there. And so don't do it. Make something that matches. All right, that's all I got, so we'll see you on Monday.